Hello students, today in this video lecture we'll be talking about equivalent fractions. We'll try to understand what equivalent fractions are. Okay, see, these are the three figures here. Okay, we can represent this figure by, okay, there are two parts. Okay, the shaded part is one out of two parts, it means one half. Here these shaded parts are two parts out of four, that means two by 4, right? Okay, then here in this case three shaded parts out of total 6. Okay, now if we can somehow place these three figures one over the other, okay, they will appear only one, means that this and this fraction, they are actually same, right? In other words, okay, you can say, for example, if you have one biscuit, you consumed half of it. Okay, you consumed this, means you consumed one half. Okay, say for example, if you have now two biscuits, two biscuits, and you consume one, okay, out of two biscuits, you consume one out of two biscuits, right? So that means this, okay, and this, okay, are actually the same. You consumed half. Such fractions are called as, so there are the two biscuits, you consumed one. Okay, so that you consumed, okay, one half of the biscuits you had, right? Means these fractions are actually same. Okay, so see how these are same. For example, this is one half. Okay, this fraction can be put like this: 1 divided by 2 into 2 divided by 2. 2 ones are 2, 2 twos are 4. Okay, actually this 3 by 6 is equal to 1 half into 3 divided by 3. Okay, you can cancel these because numerator and denominator are same. Okay, so this is actually 1 half. You can cancel these two. This is actually 1 half. So that means these fractions are actually same: 1 half, 1 half, 1 half. See, this is 1 half of this, this is 1 half of this. Okay, these are called as equivalent fractions. Now the point is, a very important point, how we can get the equivalent fractions of a given fraction. Okay, let me ask you a question. See, 1 by 3, say for example 1 by 3. Okay, so this can be put like diagrammically. Okay, 3 parts. This is 1 by 3, right? Now there is another fraction, 2 by 7. Okay, for example 2 by 7. 1, 2, 3, 4, 5, 6 and 7. Two parts. Are these two fractions same? No, these are not same fractions. Okay, these are not equivalent fractions. Okay, see, for example, this fraction, 1 by 2, 2 by 4, 3 by 6, dash 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 36 by 72. All these fractions are called as equivalent fractions. Because, why? Because they represent the same part of the whole. Same part of the whole. And these are not equivalent fractions because they do not represent the same part of the whole. Okay, now the question is, why do the equivalent fractions represent the same part of the whole? how we can obtain one from the other. For example, this is 1 by 2, that is equal to 2 by 4, I can say, because this 2 by 4 is equal to actually 1 by 2 into 2. We are multiplying, actually 1 by 2 is actually multiplied by the same number, okay, 2 by 2 by its denominator and numerator. 2 1s are 2, 2 2s are 4. If we again multiply this 2 by 4 by the same number through its numerator and denominator, we get 2 2s are 4, 2s are 6. That means 1 by 2, 2 by 4 and 4 by 6 are actually the equivalent fractions. Okay. Now for example, you are given a fraction 1 by 3, for example, and you are asked to obtain its equivalent fractions. Okay, one way of getting equivalent fractions is just by multiplying, okay, the same number to its numerator and denominator. 2 by 2, we get 2 1s are 2, 2 3s are 6. Then again 2 by 2, which is equal to 2 2s are 4, 6 2s are 12. Then again 2 by 2, okay, 2 4s are 8, 24. All these are this, and this. All these are equivalent fractions. Another way to get the equivalent fractions is to divide. For example, if we divide 2 numerator and denominator to this fraction, we get 2 4s are 8, 2 12s. Okay, again divide 2 by 2, we will get 2 2s are 4, 2 6s are 12. Right? If we again divide this by 2 by 2, we will get 2 1s are 2, 2 3s are 6. These are it is called as the equivalent fractions. So equivalent fractions can be obtained by multiplying or by dividing. Okay, this dividing by the same number, multiplying and dividing by the same number, its numerator and denominator, right? Okay, so these were the equivalent fractions, right? Okay, let me tell you an interesting fact about equivalent fractions. See, these are equivalent fractions, 1 by 3 and 3 by 9, right? 1 by 2 and 2 by 4, these are again equivalent fractions. 2 by 3 and 4 by equivalent fractions. Okay, now try multiplying this numerator of first fraction to the denominator of second. So 9 1s are 9. Then numerator of second to the denominator of first, okay, which is equal to 3 3s are 9. Okay, so 8 will come out to be the same. 9 here, 9 here. Okay, let's try here. Numerator of first means 1, denominator of second fraction, 4 1s are 4. Numerator of second, denominator of first, 2 2s are 4. This is called as cross product. Okay, numerator of first and denominator of second, right? Numerator of second and denominator of first. Okay, so this is called as cross product. The cross product of, remember, the cross product of equivalent fractions is always same, that is equal. Okay, see, 9 9 4 4 12 12, right? There are some other interesting facts about these fractions. Okay, in the next video part we will talk about those those interesting facts about fractions. For example, simplest form of fraction that stands undiscussed so far. Okay, we will discuss that. We will also discuss in the upcoming videos that what is this, what are the like fractions, what are like fractions. Okay, then we will try to compare various fractions, comparing fractions. Okay, we will talk about how to compare like fractions. Okay, and then finally comparing unlike fractions. Okay, now before that there is one important thing, how to represent these improper fractions of a number line. Okay, so we will talk about that. See, this is improper fraction. We have to represent this on a number line. See, what will you do? 8 divided by 5. Okay, 8 divided by 5 is an improper fraction, right? This is greater than 1. Okay, this will be somewhere on the number line beyond 1. So for example, this is 0. Okay, say for example this is 1. Okay, so numerator is here 5. We will divide this distance into 5 equal parts. 1, 2, 3, 4, 5. Okay, 4 and 5. Okay, this is 0, this is 1. Then 6. Okay, now focus on this. 6, 7, 8. Okay, now we have to divide this distance into 5 equal parts. This will be 0 by 5, right? This will be 1 divided by 5. This will be 2 divided by 5. This will be 3 divided by 5. This will be 4 divided by 5, and this will be 5 divided by 5. Okay, but among these fractions, okay, this cannot be located. But this part beyond 1, this will be 6 divided by 5. This will be 7 divided by 5, and here it will be the 8 divided by 5. Now why? Okay, try to convert this into mixed fraction. Okay, you will get 5 plus 3 divided by 5. Okay, that means 5 3 by 5. Sorry, one whole means 1. Okay, so it's called in this way, 5 divided by 5 plus 3 by 5, right? So that is called 1 whole plus 3 by 5. Okay, this is its mixed form. 1 whole, see here, 1 whole and 3 by 5. 1, 2 and 3. Okay, so this means 1 whole by 3 by 5, right? Okay, so this is how we can represent an improper fraction on a number line. Okay, let's take one more example. 7 divided by 3. Okay, this is again an improper fraction. Okay, let's try converting this into a mixed fraction. This means 3 plus 3 plus 1 divided by 3 means 3 by 3 plus 3 by 3 plus 1 by 3 means 1 whole means 2, 1 by 3. Okay, so you can divide first a number line into, okay, this is a whole number 1, this is whole number 0, this is whole number 1, divide it into 3 equal parts, 1, 2 and 3, 1, 2 and 3. Okay, but the numerator is 7. Okay, dividing this number line beyond 1 into 7 equal parts, 1, 2, 3, 4, 5, 6, then 7, right? Okay, so this will be 0 by 3, this will be 1 by 3, 2 by 3, and this will be 3 by 3. The numerator and denominator same, that means which is equal to 1 whole. This will be 4 by 3, this will be 5 by 3, this will be 6 by 3, this will be 7 by 3. Okay, 7 by 3 means 2 whole. 2 whole means 1, 2, 3. This means 1 whole, 1, 2, 3. This means another whole. Then 1 by 3. This is 1 by 3. Okay, so this is equal to 2, 1 by 3. Right? Okay, so that means 7 by 3 is actually equal to 2 whole and 1 by 3. This is 1 whole, 3 parts. Another 3 parts is another 1 whole, and then this is 1 by 3. Okay, this means 1 out of 3 parts. That means which is equal to 7 by 3 or 2, 1 by 3. So this is how we can represent these improper fractions on a number line, right? Okay, in next video lecture we will talk about some other interesting facts about these fractions. Till then, Khuda Hafiz.